From the roiling heart of our sun to the ephemeral electrical ballet above Earth's thunderstorms, humanity's gaze is turning skyward with unprecedented clarity, leveraging cutting-edge space technology to decode the universe's most powerful and mysterious phenomena. Recent advancements in space-based observation are offering critical new insights into both solar and terrestrial storms, promising to revolutionize our understanding of space weather and its profound impacts on our planet, while simultaneously highlighting the precarious balance between scientific ambition and political will. At the forefront of understanding Earth's atmospheric dynamics, scientists are utilizing instruments aboard the International Space Station (ISS) to meticulously study the ionosphere and upper atmosphere. This vital research focuses on phenomena such as thunderstorms, lightning, and especially the enigmatic transient luminous events (TLEs). These spectacular yet poorly understood occurrences take many forms, including blue jets that sprout upwards from cloud tops into the stratosphere, and sprites, colorful bursts of energy that dance above storms. Another type, ELVs, manifests as massive glowing rings in the upper atmosphere, confirmed by recent studies using data from the European Space Agency's ESA ASIM investigation. These TLEs are not merely visual spectacles, they can disrupt critical communication systems on the ground and pose tangible threats to both aircraft and spacecraft. By observing them from the unique vantage point of the ISS, researchers are gaining invaluable data which is already improving atmospheric models used for weather and climate predictions and shedding light on how thunderstorms influence Earth's upper atmosphere. Further investigations like ESA's Thor Davis are evaluating specialized high-speed cameras that can capture thunderstorm electrical activity at up to 100,000 frames per second through the station's cupola, offering a powerful new tool for observing severe electrical storms. Meanwhile, the Japan Aerospace Exploration Agency's JAXA Light-1 CubeSat, a compact satellite deployed from the ISS, is observing terrestrial gamma-ray flashes, high-intensity energetic events that can expose aircraft and passengers to excessive radiation. The cost-effectiveness and faster manufacturing of these small satellite detectors present a promising avenue for future atmospheric mapping. The utility of these overhead observations extends beyond atmospheric research, as evidenced by NASA's recent confirmation that the devastating damage from a May 16 tornado in southern Kentucky was starkly visible from space, underscoring the vital role of orbital monitoring in disaster assessment. Shifting our gaze further out, the sun, the ultimate driver of space weather, is also yielding its secrets to dedicated orbital missions. NASA's Punch Polarimeter to unify the corona and heliosphere mission recently unveiled its first knockout views of colossal solar eruptions known as coronal mass ejections (CMEs). These vast plumes of plasma and magnetic fields, when directed towards Earth, are the primary culprits behind geomagnetic storms, which can wreak havoc on satellites, disrupt GPS signals, and pose significant risks to astronauts. While they also supercharge the mesmerizing aurora displays, their destructive potential necessitates a deeper understanding. The Punch mission, launched in March 2025, employs 4 small spacecraft that collectively form a virtual instrument, allowing scientists to track CMEs across the inner solar system with unprecedented detail and a wide field of view. Craig DeForest, Punch principal investigator from Southwest Research Institute, expressed enthusiasm for these initial images, stating these first images are astonishing, but the best is still yet to come. He added that once the spacecraft achieve their final formation, the mission will be able to routinely track space weather in 3D across the entire inner solar system. This continuous global 3D observation of the Sun's outer atmosphere and the inner solar system is set to provide a clearer picture of how space weather forms and evolves, ultimately leading to improved forecasts that protect our vital technological infrastructure and human presence in space. The convergence of these distinct but equally critical research efforts, from understanding Earth's atmospheric electricity to predicting the Sun's volatile outbursts, underscores a unified scientific imperative to safeguard our technologically dependent civilization and human explorers from the unpredictable forces of nature, both near and far. These missions represent a significant leap forward in our ability to observe, predict, and mitigate the impacts of both terrestrial and solar storms. However, the path forward for such ambitious scientific endeavors is not without its challenges. Reports indicating a plan from former President Donald Trump to potentially cut dozens of NASA missions highlight a looming threat to U.S. space supremacy and the continuity of crucial research. Such budgetary decisions could severely impede the progress made in understanding these complex systems, jeopardizing not only scientific advancement but also the practical applications that protect lives and infrastructure. The ongoing success of missions like ASIM Thor Davis Light 1 CubeSat and Punch hinges on sustained investment and political commitment. As our reliance on space-based assets grows from communication networks to navigation systems, the ability to forecast and prepare for space weather events and extreme terrestrial phenomena becomes increasingly non-negotiable. The future will undoubtedly demand even more sophisticated observational platforms and predictive models. Pushing the boundaries of technology and our understanding of the intricate dance between Earth, Sun, and the cosmos. In a captivating display of humanity's dual pursuit of knowledge and the inherent complexities of space exploration, the International Space Station ISS continues to serve as both a cutting-edge laboratory for understanding Earth's most powerful phenomena and a nexus for the ambitious expansion of commercial spaceflight, even as the latter faces the inevitable hurdles of a challenging frontier. Recent developments highlight these contrasting facets, from groundbreaking studies of atmospheric storms to the postponement of a highly anticipated private astronaut mission. From its unique vantage point orbiting some 250 miles above our planet, the ISS has become an unparalleled platform for scientists to delve into the mysteries of Earth's upper atmosphere. Researchers are leveraging instruments aboard the orbital outpost to scrutinize thunderstorms, lightning, and enigmatic transient luminous events (TLEs) that occur in the ionosphere. These fleeting high-altitude electrical discharges, which include upward-growing blue jets and vibrant bursts of energy above storms known as sprite stratospheric/mesospheric perturbations resulting from intense thunderstorm electrification, are notoriously difficult to observe from the ground. Understanding TLEs is crucial not only because they can disrupt ground-based communication systems and pose risks to aircraft and spacecraft, but also because they hold the key to refining atmospheric models and improving weather predictions. The European Space Agency's ESA Atmosphere-Space Interactions Monitor ASIM, mounted on the exterior of the station, has been instrumental in collecting vital data. This data has already confirmed that lightning-like discharges at cloud tops can generate massive glowing rings called ELVs, emissions of light, and VLF perturbations from EMP events, influencing the ionosphere and deepening our comprehension of Earth and space weather. Further, ASIM-based research has characterized different types of corona discharges within thunderstorm clouds, providing critical reference points for understanding lightning initiation, a persistent problem in lightning physics. Beyond ASIM, other investigations like ESA's Thor Davis are evaluating specialized cameras for high-speed observations of electrical activity from the cupola, while JAXA's Japan Aerospace Exploration Agency Light 1 CubeSat has deployed compact detectors to observe terrestrial gamma-ray flashes, high-intensity energetic events that can expose aircraft and passengers to excessive radiation. The insights gleaned from these diverse projects are not only advancing fundamental atmospheric science but also pointing towards more cost-effective and rapidly deployable satellite technologies for future meteorological and safety applications. Yet as scientific endeavors flourish, the logistical intricacies of space travel remain ever present. The highly anticipated launch of ASIM Mission 4X4, a privately funded crewed flight to the ISS, has been indefinitely postponed, underscoring the delicate balance required in complex space operations. Initially slated for June 11, the mission, organized by Houston-based Axiom Space, faced a series of delays. The immediate cause for the latest postponement stems from a new pressure signature detected in the aftmost segment of the International Space Station's Zvezda service module. NASA is working closely with Roscosmos, the Russian space agency, to evaluate the situation after cosmonauts successfully sealed additional areas of interest and confirmed the segment is now holding pressure following recent repair efforts. This critical evaluation period necessitated the delay. Compounding these orbital concerns, the SpaceX Falcon 9 rocket, which will carry the AX-4 crew, also experienced a liquid oxygen fuel leak during pre-flight tests, leading to an earlier postponement from its initial June 8 target. High winds in the launch corridor had also contributed to previous minor delays. Despite these setbacks, the multinational AX-4 crew, led by former NASA astronaut Peggy Whitson, who holds the American record for days spent in space with 675, remains steadfast. Whitson will command the mission alongside pilot Shubhanshu Shukla of the Indian Space Research Organization ISRO and mission specialists Slas Uznansky-Wisniewski of Poland, ESA project astronaut, and Tibor Kapu of Hungary. Their flight marks a historic first for India, Poland, and Hungary in sending their citizens to live and work on the orbiting laboratory. Peggy Whitson, ever the seasoned space veteran, shared her team's status, noting on X, setbacks and delays are a normal part of spaceflight. Our AX-4 crew remains upbeat and looking forward to a safe and successful flight to the space station. Once airborne, the crew is slated for a 2-week stay, during which they will conduct over 60 scientific experiments and technology demonstrations representing 31 countries, ranging from studies on muscle regeneration to the cultivation of edible microalgae in microgravity. While the exact cost of the AX-4 mission has not been disclosed, previous ASIM space private expeditions have reportedly commanded around $55 million per seat, highlighting the burgeoning commercialization of low Earth orbit. The confluence of these events, groundbreaking atmospheric research and the operational challenges of private space missions, paint a vivid picture of the current state of space exploration. The ISS continues to prove its invaluable scientific utility, pushing the boundaries of our understanding of Earth and its environment. Simultaneously, the delays faced by AX-4 serve as a stark reminder that even with advanced technology and seasoned teams, spaceflight remains an inherently complex and demanding endeavor, subject to the meticulous scrutiny required for human safety and mission success. As the world awaits a new launch date for AX-4, the ongoing efforts to ensure the safety and integrity of the ISS, coupled with the relentless pursuit of scientific discovery from its unique perch, underscore humanity's enduring commitment to exploring and understanding the cosmos one careful step at a time. In an age where social media platforms frequently serve as stages for both genuine accomplishment and ambitious assertion, a recent incident involving a young Brazilian woman's claims of becoming a NASA astronaut has ignited a swift and unequivocal response from the U.S. Space Agency, casting a stark spotlight on the critical importance of verifiable credentials in the high-stakes world of space exploration. The controversy, widely reported by outlets such as Marca, National World, and the Daily Mail, unfolded rapidly, leaving a trail of public confusion and raising questions about digital transparency. The saga began on June 5, 2025, when 23-year-old Lisa Peixoto took to Instagram, announcing to her more than 83,000 followers that she had been selected as a career astronaut. Her post, accompanied by a photo of her in a NASA t-shirt against the backdrop of the New York City skyline, detailed ambitious plans for future manned missions to the Moon and Mars, stating she had completed NASA astronaut training in 2022 and was officially a class of 2025 astronaut. Peixoto further claimed she would join the inaugural flight of Titan space in 2029 under the command of veteran NASA astronaut Bill MacArthur, expressing immense gratitude and pride in representing Brazil as the first Brazilian woman to cross this frontier. However, the National Aeronautics and Space Administration was quick to issue a ruthless response, as described by the Daily Mail, directly refuting Peixoto's assertions. In a statement provided to multiple news outlets, NASA clarified, "While we generally do not comment on personnel, this individual is not a NASA employee, principal investigator, or astronaut candidate." The agency further elaborated that Peixoto's involvement was limited to a student workshop, emphasizing that it is not an internship or job at NASA and that it would be inappropriate to claim NASA affiliation as part of this opportunity. Further investigation into Peixoto's claims revealed several discrepancies. While Titan Space did confirm Peixoto's participation to the Brazilian outlet Metropolis, it was noted that the company itself is not licensed by the Federal Aviation Administration (FAA) to host human spaceflights, and Peixoto was not listed as an astronaut for their potential 2029 flight. Beyond her space-related claims, her academic background also came under scrutiny. The Federal University of Minas Gerais confirmed she was dismissed in 2023 for failing to register for her second semester in Columbia University, where she claimed to be enrolled in an application of computing and quantum physics master's degree program, stated they had no record of her attendance. In an apparent attempt to mitigate the fallout, Peixoto's publicist released a press statement to Brazilian outlet O Tempo asserting that the original Instagram post at no time is there a mention of NASA or that it would be an astronaut from the agency, and that the post was never edited. This clarification, however, directly contradicted reports indicating that the Instagram post had in fact been edited and that initial claims clearly implied NASA affiliation. The publicist's revised stance attempted to frame the connection as merely mentioning Bill MacArthur, a veteran NASA astronaut, as the mission commander for Titan Space rather than Peixoto herself being a NASA astronaut. This incident underscores the inherent risks and responsibilities associated with self-proclaimed achievements in the digital sphere, especially concerning highly prestigious and publicly trusted institutions like NASA. The rapid dissemination of information, often without immediate verification, can lead to widespread misrepresentation, damaging both individual credibility and public perception. For NASA, such episodes necessitate swift and clear communication to maintain its integrity and the public's trust in its official astronaut corps. As private space ventures continue to emerge and capture public imagination, the distinction between official agency roles, commercial space participants, and aspirational claims will become increasingly vital. This event serves as a sharp reminder for both individuals and the media to exercise diligence in verifying information, particularly when dealing with claims pertaining to humanity's ambitious reach for the stars. In a testament to its relentless pursuit of scientific and technological frontiers, NASA is once again making headlines with a cascade of groundbreaking initiatives that promise to redefine our understanding of Earth, propel human space exploration further than ever before, and even delve into the very origins of life. From peering into the heart of terrestrial storms from orbit to engineering revolutionary power systems for deep space missions, the agency's diverse portfolio underscores its pivotal role in shaping the future of technology and discovery. One of the most compelling areas of current research revolves around the International Space Station (ISS), serving as a unique orbital laboratory for studying Earth's upper atmosphere. Scientists are leveraging instruments on the ISS to investigate transient luminous events (TLEs), phenomena like blue jets, which discharge upwards from cloud tops into the stratosphere in colorful bursts of energy above storms, known as SPRITE. Stratospheric/mesospheric perturbations resulting from intense thunderstorm electrification. These enigmatic electrical discharges, occurring well above conventional lightning and storm clouds, are notoriously difficult to observe from the ground. Data from the European Space Agency's ESA ASIM monitor on the station's exterior are providing unprecedented insights, confirming that lightning-like discharges can create massive glowing rings called ELVs, emissions of light, and VLF perturbations from EMP events influencing the ionosphere and improving our understanding of Earth and space weather. Such knowledge is critical, as TLEs can disrupt communication systems and pose risks to aircraft and spacecraft. Further, ASIM-based research has also elucidated the physical properties of corona discharges within thunderstorm clouds, which are linked to powerful, short-lived electrical bursts and are vital for understanding lightning initiation. Complementing these efforts, ESA's Thor Davis investigation is evaluating a specialized camera capable of capturing thunderstorm electrical activity at up to 100,000 frames per second through the station's cupola windows, offering a powerful tool for observing severe electrical storms. Meanwhile, the Japan Aerospace Exploration Agency's JAXA Light-1 CubeSat, deployed from the ISS, is observing terrestrial gamma-ray flashes, high-intensity energetic events that can expose aircraft and passengers to excessive radiation. The potential for more cost-effective, rapidly manufactured small satellite detectors could revolutionize how we map lightning and thunderstorms globally. Beyond Earth's immediate atmospheric envelope, NASA is also making monumental strides in enabling future deep space exploration. Two faculty members from the Colorado School of Mines, Omid Bake and C. Michael McGurk, were recently among the 8 recipients of the prestigious 2025 NASA Early Career Faculty Award recognizing their innovative research into powering future space endeavors. Omid Bacon, Assistant Professor of Electrical Engineering, is leading a project to develop high-voltage megawatt-scale electric power and propulsion systems for spacecraft. All the spacecraft we have sent to space operate below 200 volts maximum, around 300 volts, Bacon explained, highlighting the ambition of his team's work to generate around 10,000 volts. This significant leap in voltage capacity, a tenfold increase over the International Space Station's average 70 kilowatts, could enable human travel to Mars and long-term missions aboard larger spacecraft, expanding humanity's reach far beyond the ISS's 400-kilometer orbit. Concurrently, Michael McGurk, an associate professor of chemistry, is tackling the challenge of providing reliable power for ground-based missions in permanently shadowed regions of the Moon and Mars, where solar panels are ineffective. His team is developing fuel cells that convert chemical fuel into energy without combustion, utilizing novel metal organic frameworks that act like flexible nanometer-pored sponges to efficiently store and deliver gases like methane and oxygen. These kinds of frameworks allow you to move a lot of gas, which acts as fuel in and out of the sponge with just small swings in pressure and temperature, McGurk noted, emphasizing the efficiency required for powering mobile assets the size of small cars. These innovations are not confined to space, as McGurk believes insights gained could also translate directly to sustainable fuel cell technologies on Earth. Further underscoring the breadth of NASA's scientific inquiry, the agency is also facilitating research into the origins of life itself. Following the successful retrieval of an asteroid sample, researchers at institutions like the field are now poised to probe this extraterrestrial material for clues that could unlock fundamental secrets about how life began. In the realm of aeronautics, NASA continues to push the boundaries of flight. Its F-15 aircraft have been instrumental in validating shockwave tools for the X-59 supersonic flight project, a critical step towards realizing quiet supersonic air travel and potentially revolutionizing commercial aviation. Collectively, these diverse endeavors paint a vivid picture of an agency at the forefront of innovation. From safeguarding Earth's atmosphere and advancing our understanding of weather to engineering the next generation of spacecraft power systems and even exploring the cosmic genesis of life, NASA's current projects promise not only to expand human capabilities in space but also to yield invaluable benefits and technological spin-offs right here on Earth. Charting a course for a future where the impossible becomes routine, the Red Planet continues to yield a trove of astonishing discoveries as NASA's fleet of robotic explorers delivers a flurry of groundbreaking insights that are rapidly reshaping our understanding of Mars. From successful drilling operations uncovering geological secrets to capturing the first visible auroras and intimate portraits of its moons, the recent wave of data paints a vibrant picture of an active, dynamic world, even as potential policy shifts loom on the horizon for future space endeavors. At the forefront of these scientific triumphs, NASA's veteran Curiosity rover has achieved a significant milestone, successfully drilling into the Martian surface at a site dubbed Altadena. This critical operation, completed over Sol's 4566 to 4567, marks another step in the rover's decade-long mission to unravel the geological history of Mount Sharp. Following telemetry confirmation and subsequent imaging, the drilling activity proved successful, enabling the mission team to proceed with delivering the collected sample powder to Curiosity's sophisticated onboard instruments CMEs and SAM. It is always exciting to find out what each of these instruments uncovers from Martian samples, remarked Michelle Manitti, a planetary geologist at Framework and a member of the Mars Science Laboratory mission team. CMEs is poised to provide distinct and valuable insights into the sample's mineralogy, while SAM will analyze its volatile and organic compounds, both crucial for piecing together the complex history of the region. Beyond the core sample analysis, the mission team also conducted ChemCam RMI remote microimager observations of the drill hole to refine future laser targeting, performed passive spectroscopy of the drill cuttings for mineralogical insight, and captured a mast cam image to monitor wind activity and cutting stability. The efficiency of the weekend's operations even allowed for additional scientific observations, including more chem-cam data from nearby bedrock at Bolsa Chica and long-distance mosaics of sedimentary structures within Texeli Butte alongside routine environmental monitoring. Adding to Mars's mystique, the Perseverance rover has recently documented a phenomenon never before seen by human eyes on the red planet, a visible green aurora. While scientists had previously detected various types of Martian auroras, these had always occurred at ultraviolet wavelengths invisible to the naked eye. This groundbreaking observation, captured by Perseverance in March 2024, directly links the green glow to high-energy particles unleashed by an intense solar storm eruption. Auroras, a spectacular display of light, occur on both Earth and Mars when energetic particles from space bombard the upper atmosphere, interacting with magnetic fields. However, Mars presents a unique case. Unlike Earth's global magnetic field that guides these particles predominantly towards the poles, Mars lacks such an organized planetary field. Consequently, the incoming solar particles can rain down anywhere across the Martian atmosphere. The presence of visible aurora opens a new avenue for the study of space weather events at Mars, noted Elise Wright-Knutsen of the University of Oslo, who led the study published in Science Advances. The aurora appeared on March 18, 2024, 3 days after a coronal mass ejection on March 15, strongly suggesting its origin from charged energetic particle interactions as the solar storm's shock front reached the Martian magnetosphere. Further enhancing our visual understanding of Mars, the Perseverance rover also captured a stunning albeit faint image of Deimos, Mars's smaller moon, glimmering in the pre-dawn twilight. Taken on the 1433rd Martian day of the mission. This mesmerizing snapshot was achieved by pushing the rover's left navigation camera to its limits, employing an extended exposure time of approximately 52 seconds. From the Martian surface, the diminutive 12-kilometer diameter moon appears more like a bright star than a conventional lunar body due to its small size and vast distance. The resulting image, while hazy from the dim light and digital noise, reveals not only Deimos but also artifacts from cosmic rays, and notably two prominent stars from the Leo constellation, Regulus and Algeba. Below the celestial canvas, the faint Martian landscape includes features like Woodstock Crater, located less than a kilometer from Perseverance as it continues its journey towards Witch Hazel Hill. Deimos, along with its larger sibling Phobos, remains an enigma, with researchers debating whether these tidally locked moons are captured asteroids or formed from debris ejected during ancient Martian impacts. These remarkable scientific achievements underscore a period of intense discovery and expansion of our knowledge about Mars. However, the future trajectory of such ambitious space exploration may face headwinds. Recent reports indicate a potential Trump plan to cut funding for or even terminate dozens of existing NASA missions. Such a policy shift, if implemented, could pose a significant threat to the United States' long-held leadership in space and severely impact the continuity of critical scientific research. The delicate balance between sustained political will and the profound scientific breakthroughs achieved by missions like Curiosity and Perseverance highlights the ongoing tension between ambition and resource allocation. As humanity delves deeper into the mysteries of the Red Planet, the insights gleaned from these missions are invaluable. Not only for understanding Mars's past and present but also for informing future human endeavors. The successful drilling at Altadena, the captivating visible aurora, and the intimate view of Deimos all contribute to a richer, more nuanced picture of Mars, one that continues to inspire and challenge. The path forward for Mars exploration will undoubtedly be shaped by both the relentless pursuit of scientific knowledge and the prevailing political landscape, determining whether the current momentum of discovery can be sustained or if future revelations will be constrained by budgetary and policy decisions. The celestial ballet of near-Earth objects continues to captivate and occasionally concern astronomers, with recent observations by NASA dramatically shifting the focus of a potential cosmic collision from Earth to its silent companion, the Moon. Asteroid 2024 YR4, a building-sized object estimated to span 174 to 220 feet 53 to 67 meters, which was briefly considered the most dangerous space rock tract. now poses a significantly higher, albeit still small, chance of impacting the lunar surface in 2032. Discovered on December 27, 2024, asteroid 2024 YR4 immediately drew the attention of astronomers due to initial projections showing approximately a 1% chance of it colliding with Earth on December 22, 2032. This probability briefly escalated to a concerning 3.1% following follow-up observations, marking it as the most significant threat since tracking efforts began. However, as more refined data became available, particularly from the James Webb Space Telescope JWST, the immediate threat to our home planet diminished dramatically. NASA's updated calculations now place the odds of an Earth impact at a reassuringly low 0.004%. The sigh of relief for Earth, however, has been tempered by a revised outlook for the Moon. As planetary scientist Dr. Andrew Rivkin from Johns Hopkins University in Maryland explained to IFL Science back in April, the odds of an impact into the Moon have always been there. It's been lower at that time because the Earth was a bigger target. The way that the orbit improved made the position move away from the Earth, but it moved toward the Moon. Initially, the object had a 3.8% chance of striking our natural satellite. Now, following further meticulous observations by JWST and analysis by NASA's Center for Near-Earth Object Studies CNEOS at the Jet Propulsion Laboratory JPL in Southern California, this probability has been marginally increased to 4.3% for December 22, 2032. On that date, 2024 YR4 is projected to pass within a mere 0.00007 astronomical units AU of the Moon, with $1 being the average distance between the Earth and the Sun. While the prospect of an asteroid of this magnitude hitting Earth would be catastrophic, a lunar impact conversely is viewed with considerable scientific excitement. Richard Moisel, the head of ESA's Planetary Defense Office, indicated in February that such an event would be visible from Earth and there would even be new lunar meteorites that would arrive on Earth, nothing dangerous. He added, definitely a new observable moon crater would be the outcome. NASA reassures the public that even if 2024 YR4 were to strike, it would not alter the Moon's orbit, preserving its gravitational dance with Earth. Current calculations suggest a 95% probability that the asteroid will bypass the Moon entirely. Further scrutiny of 2024 YR4 has revealed intriguing details about its composition. Infrared observations by the James Webb Space Telescope in March estimate the asteroid to be rich in silicates, a finding that suggests it may have originated as a fragment from the surface of a larger asteroid. Astronomers also believe that its current trajectory, which brought it into proximity with our celestial neighborhood, is likely the result of gravitational interactions with Jupiter. At present, asteroid 2024 YR4 is too distant for ground-based or space-based telescopes to obtain a clear view. However, NASA plans to conduct further observations when the asteroid's orbit around the Sun brings it closer to Earth again in 2028. This future opportunity will allow scientists to refine its trajectory even further, providing more precise predictions for its 2032 close approach and potentially offering an unprecedented opportunity to witness a significant impact event on our closest cosmic neighbor. The ongoing monitoring underscores the critical role of planetary defense initiatives not only in safeguarding Earth but also in advancing our understanding of the dynamic solar system we inhabit.